Okay, a conical flask contains potassium iodate, potassium chlorate, and potassium arsenate all in solution. So what you need to be able to see is in this solution, there's iodate, there's chlorate, all right, and there's arsenate, AsO4 3 minus. Okay, you have all these. All right, so what you're going to do is you're going to throw in Ag plus. Okay, silver nitrate will added incrementally until the first BPT occurs. What is the concentration of silver ions present? Okay, so this one also you need to actually do your calculation. All right, so just very quickly, in order to precipitate out, say silver, so silver iodate. Okay, in order to precipitate silver iodate, the ionic product must be equals to the KSP, isn't it? So you do this, all right, and the ionic product will be Ag plus times IO3 minus equals to the KSP, which is 3.2 times 10 to the power minus 8. So you have the concentration of all of them. Oh, all of them is 0.1. I could see that the iodate is 0.1, the chromate is 0.1, arsenate is also 0.1. So this is actually 0.1. Okay? So which means you can actually calculate the concentration Ag plus for this one. Okay, so it's going to be 3.2 times 10 to the power minus 7. Okay, moles per dm cube, of course. Okay, let's try the next one. Let me see. Okay, so you're going to do the same thing to precipitate out. Maybe I'll just write over here. To precipitate out silver chromate, right? Silver chromate. So it's Ag2CrO4. So same thing, ionic product must be at least minimally equals to the KSP, right? So you're going to calculate the Ag plus that's needed to precipitate out silver chromate. Okay, so the ionic product, okay, Ag plus square CrO4 2 minus, all right, is equals to the KSP, which is 9 times 10 to the power minus 12. So you can again calculate what's Ag plus, all right? So I'm just going to put in the value, this is 0.1. Okay, equals to 9 times 10 to the power minus 12. Okay, work it out. Okay, this will you get Ag plus is equals to, let me check the value, it should get 9.5 times 10 to the power minus 6. Okay, moles per dm cube, of course. All right, so to precipitate out, okay, just use a different color. Okay, to precipitate out silver arsenate. All right, so again, the same thing, ionic product is equals to the KSP. Right, so it's going to be Ag cube, all right, AsO4 3 minus, right, equals to KSP, which is 1 times 10 to the power minus 22, and this value is again 0.1. Okay, so work it out. I'm just gonna do the math. Okay, Ag plus, you get a concentration of 10 to the power minus 7. All right, so if you look at the three values, this is the amount of Ag plus that you need to put in, the concentration, before you see a PPT. So these are the values. So the one where the first PPT will appear is where the silver plus concentration is the smallest, right? It's actually the smallest. So you can see that in fact, which one is the smallest? In fact, this is the smallest, right? This is only 10 to the power minus 7. Okay, so which means this answer would be C. Okay, this answer would be C. Okay.